All right, so in this video, we're doing questions 51, 52, and 53. So I know 51 was a part of the last set of problems, but I want to do 52 and 53 as well because they all involve the same items, balls and marbles. So let's go back up and read 51 first, and let's take a look at our rules that we just went over. So 51 says a bag contains 19 balls numbered 1 through 19. What is the probability that a randomly selected ball has an even number? Okay, this is a simple probability question. So we know that our sample space is a set of numbers from 1 to 19. So natural numbers that are less than or equal to 19. So put the ellipse, stop at 19. And the event is the set of even numbers. So our event E is the set of all even numbers between 1 and 19 inclusively. So that's 2, 4, 6, 8, 10, 12, I'll list them all out, 14, 16, and 18. So to find the probability of an even number, that is the cardinality of an even number divided by the cardinality of numbers. Numbered balls in this case. And I'm going to erase this because I want to edit it. Even balls. When you count the number of even balls in the set, you have 9. Once again, if you count all the numbers in this set up here, that is 9 values. So let's put that actually in red. Divided by the number of elements, the number of numbered balls, that is 19. So the probability of choosing an even numbered ball is 9 out of 19. Now, why did I drag that out? Because I want to show you, right, where the answers are coming from and how to apply it to the next set of questions. Because now we're going to get into 52 and 53, which are some of my favorite type of questions. So 52 says, assume that 2 marbles are drawn without replacement from a box with 1 blue, 3 white, 2 green, and 2 red marbles. Find the probability of both marbles being red. So without replacement, that means that when I take the first marble out of the box, I am not replacing it. So there are 10 marbles in total. No, there are 8 marbles in total when you add them up together. So on my first attempt, I have 8 possibilities. But then on my second attempt, I'll have 1 less because I didn't replace the marble. So that means I have 7 possibilities. The first event affects the probability of the second event. That's kind of different from what we talked about earlier when we went over independent events for question 47. Question 46. In this case, the event for 52 is dependent. So for 52, write it down here. 4 dependent events. Let A and B be events such that event B is dependent on event A. Then the probability of event A and event B occurring equals to the probability of event A times the probability of event B given that event A has already occurred. And this ties right back up into conditional probability. Matter of fact, you can derive the conditional probability formula from the multiplication rule of dependent events. So in our case, for 52, to find the probability that both marbles are red, that 2 red marbles, this equals to the probability that the first marble is red and the second marble is red. By the multiplication rule in this case, this equals to the probability that the first marble is red, and that's times the probability the second marble is red, given that the first one was red, because the second drawing is dependent on the first one. So I'm going to use red for the marbles. So we already established in number 52 that there are 10 marbles in total. 10 marbles in total. Out of the 10 marbles in total, 2 of them are red. So to find the probability that the first marble is red, that is going to be 2/10. 2 red marbles out of 10 marbles in the box. I'm going to reduce this fraction from 2/10 to 1/5. Now we're going to multiply that with the probability the second one is red, given the fact the first one is red. So, because I removed 1 red marble out of my box, there is now 1 red marble left for me to choose from. And because I removed 1 marble out of the box, there's no longer 10 marbles for me to draw from, but now there are a total of 9 marbles for me to select. So that means the probability that the second marble is red, given the fact the first marble was also red, that is 1/9. And that cannot be reduced any further. That is 1/9. And when we multiply fractions, we multiply our numerators and our denominators. So that's going to be 1/45. And I'm going to leave it as a fraction. The answer may have the final answer as a decimal, but let's leave it as a fraction. There you go. Now, I'm going to move on to 53 in a second, but I also kind of want to point something out. Before I simplify, right, this is just a note. Before I simplify the fractions, if I multiply them, that's 2 times 1 on top, and the bottom is 10 times 9. And also, we know the order matters in this case. We must choose the first one red. The second one is also red, but still there's an order to it. And when you're choosing, you're not replacing the items. These are actually familiar to permutations. The numerator is the permutation of 2 and 1, and our denominator is the permutation of, the numerator is the permutation of 10 and 2. The numerator is the permutation of 2 and 2, and our denominator is the permutation of 10 and 2. What does permutation mean? Multiply natural numbers in descending order. So I'm starting with 2, and I must multiply 2 numbers counting down. So that's 2 times 1. This permutation on the bottom means I'm starting at 10, and I'm multiplying 2 numbers counting down, which is 10 times 9, which still gives you the same answer that we have down here. So this is more of just a curiosity, more of a note. Okay, let's read number 53. A bag contains 10 white marbles, 12 blue, 13 red, 7 yellow, and 8 green wooded balls, so not marbles. A ball selected from the bag and the color is noted, then it's replaced. Then you draw a second ball, note its color, and replace the ball. What is the probability of selecting 2 red balls? Round your answer to the nearest 10,000s. So that means round your answer to 5 numbers after the decimal, if possible. All right, so 53. We have 50 balls in total by my math. 10 plus 12 is 22, plus 13 is 35, plus 7 is 42, plus 8 is 50. And you want to find the probability of 2 reds. So the probability that having 2 reds, which equals to the probability that the first one is red, and the probability the second one is red. Okay. So will this be similar to like number 52? The answer is, of course, it is similar to number 52, but it's not the same. The reason why this is different is because it says the ball is replaced. So that means for the first selection, there are 50 balls you can choose from. You take one out, you note its color, and you put it back, which means for the second attempt, there are still 50 balls left from you to choose, which means the first event will not have an impact on the probability of the second event. These events are independent. So these are independent events. And we already discussed independent events in the last video. So it's going to equal to the probability that the first is red times the probability that the second is red. But because it's independent, you do not need the condition that the first one may or may not be red. So the probability of the first one being red, that is going to be 13 out of 50. So 13 out of 50 are red. You take one red and you replace it back into the box. So that means the probability of the second one being red is also 13 out of 50. And now we can multiply. This equals to 169 divided by 2,500. And we're now going to round to 5 numbers after the decimal. And that's going to equal to exactly 0.0676. And we round it accordingly. This is correct, actually. This is an exact value. All right. So hopefully you see the difference between independent and dependent events and how the word replacement and non-replacement affects the quality of the problem. All right, guys. I'll catch you in the next one. Take care.